Okay, so I'm going to give I hope it's a really, really short talk about CViT. It's a little talk, little tool. This is the chromosome visualization tool. It's misnamed. It should really be a genome visualization tool. But GViT didn't give us such a cool mascot as CViT did. In a nutshell, it's a pro utility, rich GFF files, produces pings and SVGs. Draws features on genomic backbone. And this backbone can be anything that's sequential. It can be chromosome, config backs, linkage groups, pseudomolecules, literal chromosomes, big cytological stuff. And the feature can be just about anything, loci, repeat density, blast split, etc. Anything that can go onto a chromosome. It supports, I want to say all chromosomes, all coordinate systems that are linear, that have increasing or decreasing unit, but I'm sure someone will come up with one that doesn't support. Doesn't do logs, for example, log scale. So as long as it's linear, always goes up or always goes down. And then it's designed for overview images. You can do close-ups, but I think there are better tools for doing that. And it's been used for data mining, looking for patterns in data on the whole genome, producing images for papers, and toward the end I'll show how you can turn it into an interactive tool. So what can you do with it? You can draw your chromosomes. This is the maize genome. You can draw both strands if for some reason you have features that differ from the two strands. Add centromeres, gene densities, and at this point you can start looking at it and find patterns. So one thing that puzzled me for a long time was this little thing that sticks out here, and then I found out finally after a few years of staring at that's a bit of mitochondrial DNA that got sucked into the nuclear DNA and then replicated itself. Yeah, and there's some other interesting things up here. But typically, you see the dense written ends and narrower in the middles, but then there's some interesting peaks. So at this point, you can start looking at some patterns. So I just did some research last summer. A knob, it's a feature that appears in maize, grasses, Drosophila, some other organisms. And it's an area we have thousands of repeats that clump the chromosome together, and it's visible under a microscope. And this was actually an early method for genotyping. Maybe have been one of the first methods for genotyping in maize. Different lines have different knobs. And so this research, most of which came out of the Kelly Dahl lab, got some regions where the knobs typically appear in different lines. And the knobs are characteristic, so we painted one of those knob repeats onto this picture, and we were thrilled to find this is the inbred line called B73 that was used to do the reference genome. And B73 knob is right here, and here we found the replicated data, or the repeat. And it's got another one up here, and again we found the repeats up in there. So this allowed us to do some data mining and helped us reduce the regions where we expect the knobs may be found. But also, this is a demonstration of one call to CViT. You can produce a picture that gives you the chromosomes, centromeres, gene densities, knob regions, flanking markers of the knob regions, and the hits, the repeat densities. And this resulted in a paper. You're not limited to physical base pair type pictures. You can do genetic maps. Of course, most genetic maps now are a little too dense to be seen this way, but it is possible. This also demonstrates that CViT can deal with chromosomes that have different start positions. And you can also turn on a switch that allows variable spacing. So if you have a big genome and you want to squish stuff in as tightly as you can use this. And this data came from this map, a memorable maize map. You show cytogenetic maps. Again, they can't be too dense or they're hard to see at this level. This is an example of a scale. This is using Sentiment Clintox, which goes from -1 to +1. So you can deal with fractional scales. And this comes from this paper. CGH data. This shows structural variation between on 2 lines. I don't know if you can do more than 2 lines. There's a No17 popular inbred that a lot of research is done on. And then here's B73, which tries on. It's not too much different from itself. So you can see regions. I believe that this indicates there's very little variation between the 2 lines. I think if I had a stretch with nothing showing that would be a place where there had been a deletion in one line or the other. And this data came from this paper. This is an old one. The history of this tool is usually developed to show the, for the metacausal sequencing project way back when. We wanted to show the state of the back sequencing. And so we lined up the backs along the chromosomes in different colors. And then showed, can't see the colors here very well. There are gray things that show gaps, presumably. Right? And then different colors to show the backs in different phases. And then this is showing disease resistance gene densities along the backs. You can also use it to show internal synchrony, homeologous regions inside a polyploid. So this pretty picture is showing the duplicated areas, chromosomes one color, and you look across to find others. Let's see if this is an easier one to see. So you can see there's pieces of it here and here and so on. And this comes from Legume Information System. I'll just quickly run through this nomenclature. We call it chromosome. It's actually a backbone. This is used for placing the feature. A feature, you've got a position, which is a dimensionless feature. A range has length. Marker, this is really a specialized position that is kept around for legacy reasons. Border, this goes directly on top of the chromosome like the backs in the previous picture. Centromere is a specialized border. And then the measure is a feature. It may have length or not, but it has a value which can be displayed as a heat map or a histogram, or a distance is in the CGI image. So pretty much everything can be controlled through the configuration file. This is a very long file. This is general stuff. And then each glyph type has its own section. And this goes on. You can also group your features by type. I really like the feature group idea because I'm so used to thinking about features like this. So if you have multiple types of features that are positioned, you can use, declare them to be a particular type and then change the color or put them on one side or the other of the chromosome. Use a different image, a different picture to represent them. GFF format comes in. This is what it interprets. ID and name, which are treated as the same thing. Class, color, and value. Class is one of the ways that it separates the features out into different groups. It's a command line thing, tool. Just a few things to mention here. You compile in as many GFF files as you want. This is a little messy, but it's really handy. You can override any of the configuration file settings with a -S. And this is very helpful if you're trying to tweak your image so you don't have to keep editing your config file. Or if you're producing a whole set of images that are similar, then maybe you have just one little difference in them. And you have to have one record type of chromosome or it won't draw you a picture. Okay, so it's a fairly simple tool. It's just producing a static picture, but you can make it interactive. And given that if you don't have too many features, it draws very quickly. You can look pretty spontaneous. So one way this has been used, this is Legume Information System is using it for BLAST. So it's a typical BLAST interface. And it will return a picture that looks like this. So in addition to producing a image, it also produces a CSV file, and this gives you the coordinates of everything that's drawn onto the picture. So you can then use this CSV file to create an image map. And moreover, if you've got attributes in a GFF file that you didn't know what to do with, it will just carry it on and pass it through the CSV file. And so that's how this mouse over box was produced. So you found the position of that point, did a grabbed the attributes that came along and put it into this box, and then included a link to GBrowse. So it's open source, it's at SourceForge. I know that's no longer the hip thing to do, but that's where it is. The code, well, it's not sophisticated. My goal was to make it very simple so that a grad student in a biology lab who had a couple of programming courses could get in and play with it. It's gotten big enough that I don't think that's true anymore. And then there's some helper scripts that come along with it to start people dealing with GFF files. And then acknowledgements by co-developer Ethy Cannon, and all these people who have worked with it or given me advice on how to improve it. And that's all.
Questions? I do. A few.
Oh.
First, are civets the thing that eat the coffee beans and then
Could be, yeah.
they poop them out and people collect them and make coffee out of them? Very expensive.
Yes, that's right. That's right. I forgot about that.
Okay. I was trying to remember if that was the thing. Yes, but what expensive thing do they poop out? Okay, that's cool. And I'm guessing it sure looks like you're using biographics under the hood.
Yeah, actually, one thing I'd like is if anyone has advice for better graphics, so it's using GD.
Yeah, right. It's not using biographics, but it is using GD?
It's using GD.
Okay.
Because I'd love to make
certainly,
the pictures prettier.
Well, and one of the things that makes biographics so identifiable is how awful the fonts are. But you can get GD to use TrueType fonts.
Yes,
and so if you using TrueType fonts is a marked improvement.
Yeah.
So that's one thing.
Some of the pictures.
Well, it's funny. That's why I wasn't sure actually, because some were better than others.
Yeah. Well, particularly the last one that I showed was a really old picture.
Yeah. Okay.
So one of the things we found is that you can get a lot of rather nice graphics, but sadly you have to learn some art.
Oh,
so there's a lot of things you can do in R beautifully with very little code, especially for graphing type things.
Yeah.
So miles better than GD, and R is installed in most platforms now.
Yeah.
Yeah, statistical package.
Oh,
but it's got
so I
lots of
thought
graphical
that's
tools,
what you were talking about. Okay.
Yeah.
Yep.
Okay, very good. Thank you.